Grand almost got it. And, the old days. Are we supposed to do any other row with the X?
Yeah, space yourself out of this. That's what you said together.
Yeah, I think we're good. So.
Oh, yeah.
As soon as you're ready to start talking, turn it on.
So just give you a heads up. We have a group that works on trained dogs so that the people with disabilities.
That happens, yeah.
Have you seen the work that says slides?
Okay, so that's good, and then I turn it on.
Test it.
Test.
Good, perfect.
Okay.
Yeah, do you want to? Yeah, I can use it. Should I use that instead of either one? I'll just use that. I'll just use that. Perfect. So, perfect. I was looking for it. You're supposed to be number one. He's not watching.
Okay, I think we'll get started. I want to thank everybody for being here. One of our first in-person events. It is great to see people in full 3 dimensions. Some of you have sort of been burned into my memory as 2-dimensional entities from thousands of Zooms. So welcome everybody, and thanks for coming out, and welcome to the people who are online who are still 2-dimensional, although I can't see them at the moment. This is the Fralin Biomedical Research Institute Maury Strauss Distinguished Public Lecture, and I want to especially thank Mr. Maury Strauss, who's not here this evening, but Steve Strauss is here. I want to extend our thanks very much, Steve and the family, for this lecture that they've endowed, which has been so valuable to the community. Also, before introducing tonight's speaker, I want to put in a quick plug for the next and last installment in the series this year. That will be on May 5th, the final speaker in the Distinguished Public Lecture Series for the year. And that'll be Dr. Ben He. He's a professor in the Department of Biomedical Engineering at Carnegie Mellon and a fellow of the International Academy of Medical and Biological Engineers. And he'll be speaking on dynamic brain mapping and brain-computer interfaces. So that's May 5th. That'll be the last one. And then you'll be hearing about us for the next round of fantastic speakers starting up in the fall again. Okay, so it is my great pleasure to introduce today's speaker, Dr. Deborah Tucci. Dr. Tucci is the director of the National Institute of Deafness and Other Communication Disorders at the NIH. We were just having a discussion about how many directors there have been, somewhere around 3 or 4-ish before her, but not many, let's put it that way. And she is indeed the first woman to serve in the role as director of NIDCD. She has a background that includes her education as an undergraduate degree and medical degree up the road in Charlottesville at the University of Virginia. She studied audiology and speech pathology, and then went on actually in between to get a master's degree at the University of Michigan in audiology, and then back to medical school in Virginia. Then she went back to Michigan for a surgery internship, and then she came back to Charlottesville for a residency in otolaryngology and head and neck surgery. And then she went back to Michigan for a fellowship. So there was this kind of Michigan-Virginia thing going on for a while. I haven't asked her about the details of that, and she also picked up an M.B.A. at Duke University after that, after her medical training. She has had, through her professional career, faculty appointments to full professorship in otolaryngology, head and neck surgery at the Department of Surgery at Duke University, and also through the VA, including in Asheville, North Carolina. And she's the co-founder of Duke's Hearing Center and directed their Cochlear Implant program while she was there. Her research has touched on a lot of areas related to hearing and communication. She's combined clinical and surgical practices, for example, and skull-based surgery, and doing basic translational and clinical research. We were just chatting. I hadn't realized, I looked more closely at her resume, that she had started her research career with an old friend and colleague of mine, the University of Virginia, Ed Rubel, doing some of the early work using the avian or chick auditory system to study development of the hearing apparatus, the cochlea, and some really cool things on regeneration of cells, hair cells after damage, and so forth. She studied conductive hearing loss and contributed in that field, and the effect of noise damage on how the organization of connections coming in from the ear to the brain. And also done a lot of work regarding cochlear implants, studying things including the cost effectiveness and the impacts on the quality of life of cochlear implants, and really has taken this to worldwide studies, not just here in the United States, but looking at this treatment for people of various ages and different countries around the world. And her work has also touched on hearing loss and psychiatric disorders as well, and even getting into an economic analysis of hearing healthcare and so forth. So she's really touched the entire range of research and discovery and innovation when it comes to hearing. She's been recognized in many ways for her work and contributions. Just quickly mention one or two. She served on the Consensus Committee for Accessible and Affordable Hearing Healthcare for Adults that was convened by the National Academies of Medicine, Engineering, and Science. She took a lead role in setting up the national network of academic and community-based research sites to conduct clinical research on hearing and balance disorders, and co-chaired the Landsat Commission on Global Hearing Loss. She's been recognized by very important prestigious organizations for her contributions, including being a recipient of the Duke Medical Alumni Association's Distinguished Service Award the Jerome Goldstein Public Service Award, the Presidential Citation of the American Neurotology Society, and the Distinguished Service Award of the American Academy of Otolaryngology, Head and Neck Surgery. She's also served as president of several major associations with respect to hearing, including the Association for Research in Otolaryngology. So I'll stop now, I promise, and welcome our speaker, Dr. Tucci.
Thank you so much. It is such a pleasure to be here. I had just a wonderful day today. I met with so many faculty and had such interesting conversations. As was mentioned, I did train up the road. I spent a little bit of time in Roanoke, but I haven't been here for probably more than 20 years. So it's a real pleasure to see this new institution and see how much really great, interesting work is being done here. And it's really an honor to join you. So I will be talking today about hearing loss, and I'll focus on first talking about the impact of hearing loss, both in the US and worldwide, treatments for hearing loss. I'll touch on some of the work that we're funding to help improve treatments for people with hearing disabilities, and then talk at the end about accessibility and affordability of hearing loss treatments. So I have no financial relationships to disclose. So first, what does it mean to have hearing loss? And I think the quote that I always start with is by Helen Keller. And Helen Keller, as you know, was both deaf and blind. And so she described her experience of having these sensory disorders by saying, blindness cuts us off from things, but deafness cuts us off from people. And I think this alludes to the fact that if a child, for example, is born deaf, that child has a difficult road ahead in developing normal speech and language skills. There is sign language, and so there's a vibrant but isolated community of the deaf community that communicates by sign. Today, things are very different than when Helen Keller was born. For example, all children born in the United States, or at least 98% of them, are screened for hearing loss at birth, and therefore have the opportunity to have early intervention for hearing loss. There are more treatment options now. So children who are born deaf at birth can have an opportunity to have a cochlear implant, for example. And that cochlear implant typically will provide enough auditory stimulation for that child to develop normal speech and language and to be able to be educated in mainstream school settings. Hearing aids are also available. They're not perfect, no technology is, but there are many ways that we can intervene and improve the lives of people with hearing loss. So hearing loss has implications across the lifespan, beginning where I spoke about earlier with lack of access to spoken language and also poor educational achievement. So children who are born deaf, who don't have access to auditory communication, typically don't develop written literacy or literacy skills above the level of the 3rd or 4th grade. And so we recognize this as a challenge in treating these children. If hearing aids and cochlear implants are used consistently, then as I mentioned, those children can develop normal spoken language and have normal lives. Economic burden occurs in midlife typically. A study was done recently that showed that, that individuals with hearing loss have double the unemployment rate and half the median income of those without hearing loss in the United States. The World Health Organization has determined that unaddressed hearing loss has a worldwide annual cost of almost $800 billion. Hearing loss can lead to social isolation and stigmatization at any age, but this is particularly an issue for older adults, and I'll talk more about that later. And then there's the incidence of poor health outcomes throughout life. Dementia and depression are certainly associated with hearing loss. People with hearing loss have an increased incidence of falls, increased rates of hospitalization, and increased cost of healthcare. So the US population is aging, and the graph on the left shows that for the different age groups, the rising numbers of these populations. So in blue, ages 65 to 74, and then the decades above show as a whole, the US population is aging. The graph on the right shows that by the year 2034, the number of older adults will actually exceed the number of children for the first time in the nation's history. So you combine that with the fact that hearing loss increases in prevalence as we age, and you can see that there's a convergence of statistics that projects ever increasing numbers of individuals in the United States who have hearing loss. This will be in the millions, currently exceeds 30 million Americans. By age 70 plus, more than half of us will have hearing loss. The situation is mimicked worldwide, on the left showing the aging of the worldwide population, but it varies according to what region of the world one lives in. And this graph on the right shows as the colors get to be more red or warmer, the incidence of hearing loss increases, and the blue areas have less incidence of hearing loss. So there are some interesting patterns here. One, in low and middle income countries, you can typically look at Africa and some parts of South America, hearing loss is not as prevalent, but this may be simply due to underreporting or due to the fact that as countries industrialize, the incidence of a noise-induced hearing loss certainly increases. The areas that are the bright red are in Japan, Madagascar for reasons I can't explain, and parts of Europe. And so these are areas of the world where the population is aging. And so in the more developed parts of the world, hearing loss occurs more in the aged population, whereas in the low and middle income countries of the world, hearing loss is mostly a problem of young children. So I have a particular interest in global aspects of hearing loss, and currently, as was mentioned, I co-chair the Landsat Commission on Hearing Loss. So the journal, the Landsat, commissions these groups of experts, usually internationally, to look at a difficult problem from a lot of different perspectives, using a lot of different people with different types of expertise to make recommendations for further management of a difficult problem. And so that's what we're doing in the Landsat Commission on Hearing Loss. But hearing impairment worldwide is a huge problem that's usually underappreciated. So about 1.3 billion people worldwide have mild to profound hearing loss, which accounts for 18% of the world's population. Those with moderate hearing loss or greater comprise about 7% of the world's population. But interestingly, about 80% of these are in low and middle income countries. So this is certainly a huge problem, and usually an underappreciated and certainly undertreated problem in low and middle income countries. Hearing loss is the fourth leading cause of years lived with disability worldwide. That's a measure that's generally used to compare different conditions and the level of disability that they generate. And this comprises 6% of all disability worldwide. So these numbers, I think, indicate the importance and the burden of hearing loss as a global health concern. And this concern is expected to increase further as time goes on. So the Landsat Commission on Hearing Loss is multidisciplinary, and it includes those with expertise in auditory science, engineering, economic analyses, policy, and global health. And we're currently developing region-specific analyses and recommendations for cost-effective ways to address this problem worldwide. So the picture on the left is from Nairobi, Kenya. So I was really privileged to work with professionals in Nairobi to help develop the first newborn hearing screening program in Kenya. And this was carried out utilizing nurses who could do the hearing screening. They were trained, and a great deal of data were obtained from these studies that we're using to develop strategies for doing more universal newborn hearing screening in that country. So as I mentioned, the problem in low and middle income countries is mostly with hearing loss in children. So of 130 million children born annually, about 780,000 have significant hearing loss. And so this rate of hearing loss is 6 per 1,000 births. 90%, again, born in low and middle income countries. And the World Health Organization, importantly, estimates that at least half of hearing loss in these children is preventable. So some of the most common causes of hearing loss in children are genetic, and that's exacerbated if there is a high degree of consanguinity, which there is in some parts of the world, birth complications, infectious causes, and ototoxic drug exposure. The incidence of congenital hearing loss varies between low and high income countries. In the United States, the incidence is about 2 per 1,000 births. And in Kenya, as I mentioned, and other low and middle income countries, about 6 per 1,000 births. So what are the consequences of hearing loss, and what can we do about it? So I'm going to switch gears a little bit and really focus on hearing loss in older adults. The diagram on the left is from the Landsat Commission on Dementia. And what it shows are what they call modifiable risk factors for dementia. And I'm going to try and use the pointer here just to show you what I'm talking about. So up here, this is education. So this is in early part of life. So education is predictive of later development of dementia. These risk factors are in middle life. And so you can see hearing loss at 8% is the major modifiable risk factor for dementia. And then in later life, we have smoking, depression, social isolation, and some other factors here. And altogether, these account for 40%. So presumably, according to these data, 40% of dementia may be preventable if these conditions are prevented or treated successfully. So these data have been used by many people to say that hearing loss causes dementia directly. But is that really true? And I'm going to spend the next couple of slides talking about various theories that can explain the association between hearing loss and dementia. And these hypotheses have been labeled as shown on the right. And if hearing loss does cause dementia, then treatment of hearing loss with hearing aids is potentially a way that we can keep adults from developing dementia in their later years. But if it's not causative, then hearing aids might be very, very helpful for other reasons, but would not prevent dementia. So these diagrams that I'm showing in this slide and the following slide are from a paper that's referenced here that did a very nice job, I think, of describing what these various theories are. So the first theory that I'll talk about is the cognitive load hypothesis. And this assumes that there's a finite cognitive reserve, and that if an individual has difficulty hearing, that requires a lot of effort. So the effort and the listening effort required to really process speech is taking up a lot of that cognitive reserve and not leaving as much reserve as needed for working memory and other cognitive tasks. So if hearing loss is then addressed in that situation, then that can reduce the cognitive load and the effortful listening and get the individual back to a more normal situation where cognitive resources can be more equitably distributed. So in that case, hearing aids would be helpful. The second hypothesis is the common cause hypothesis. And this assumes that there are neurodegenerative changes that account for both the hearing loss and the dementia, and that there's no causative relationship. So in this case, while hearing aids may be helpful for hearing loss, they can't be expected to prevent dementia. The next hypothesis is the Cascade Hypothesis. And this is based on the fact that you need to have stimulation of the auditory pathways for them to maintain normal function. So it's the use it or lose it hypothesis. And combined with that are the effects of social isolation and depression and all of the other social factors that can enter in and mitigate in a negative way these changes. And so in this situation, again, the use of hearing aids or treatment for hearing loss can prevent this cascade, can reintroduce the auditory stimulation and prevent later dementia. And then the overdiagnosis hypothesis is the last one. And that implies that the diagnosis of dementia is difficult because there's an auditory impairment. So that renders the test not as accurate as it could be. And so hearing aids may be helpful in that situation, but again, not a causative relationship. So I think it's important to understand that there's not only one hypothesis. When I was in practice at Duke, it was not uncommon for me to see people in the clinic who said, I really think I may have hearing loss and I want you to identify it and treat it because I don't want to get dementia. So I think it's important to identify and treat hearing loss, but I think it's not right to scare people into thinking that they're going to develop dementia if it's not addressed. And so one way to figure all of this out is to do a study, a long-term study with a lot of patients that compares those with hearing loss who do get hearing aids and those with hearing loss who get a control situation such as hearing education. And such a study is currently being conducted by Frank Lin and his colleagues called the Aging and Cognitive Health Evaluation in Elders, or the ACHIEVE study. This is a randomized trial with about 1,000 participants, ages 70 to 84. And the study expects to wrap up sometime next year. So hopefully we'll have some definitive conclusions about whether treatment of hearing loss does in fact lead to better cognitive outcomes. So how to treat hearing loss? So devices such as hearing aids and cochlear implants are extremely helpful. They can be life-changing for many people, but they don't restore hearing to normal. So this slide shows hearing aids on the left. So this is what hearing aids typically look like, the behind the ear variety in any case. And then on the right, cochlear implants. So hearing aids are effective for hearing losses where the sound quality or the function of the inner ear hair cells is good enough that if you put in more sound input and amplify the sound, that it can be appreciated as a normal signal. In some cases, the hair cell damage is so significant and the hearing loss the hearing is so degraded that that's not possible. And so in that case, we use cochlear implants. Cochlear implants actually bypass the inner ear and directly stimulate the spiral ganglion cells and conduct the sound up through the auditory pathways to the brain. In that way, this is a surgically implanted device. So there's a portion of the device that's implanted into the inner ear. There's a magnet that sits under the skin, and then there's a receiver that is located behind the ear with a magnet that sits over the portion that's implanted under the skin. This is one variety, and another variety has everything contained in just a disc that sits behind the ear. These are extremely useful devices. And I think one of the joys that I had as a surgeon, as a practitioner, was doing cochlear implants, especially in older adults who had lost their hearing over time. They were frequently brought in by family members who said, you know, my grandfather used to be the life of the party, and now he sits at the Thanksgiving dinner table and can't even participate in the conversation, is getting depressed and is socially isolated. So cochlear implants are so successful in this population and can be implanted late in life very, very safely. But the Holy Grail, and what I hope we will have in the future, is medications, drugs, and other molecular interventions that can actually prevent or treat hearing loss. So that's really the Holy Grail. The most common causes of hearing loss are genetic, infectious, presbycusis or age-related, and noise-induced hearing loss. In the top is just a little diagram. So the inner ear is located very deep in the skull. It's about a third of the way into the head. And you can see the coils of the cochlea here. The cochlea is right here. This is the hearing organ, and then this is the vestibular organ. And within the cochlear sensory epithelium, the basilar membrane, are these hair cells. And the hair cells are stimulated by the sound in the fluid-filled chambers of the inner ear. And stimulation of the hair cells is what causes the firing in the auditory nerve. So once these hair cells are damaged, they do not repair. And that's the reason why hearing loss is generally permanent. It was discovered, however, in Ed Rubel's lab in 1988 that avian species, chickens, do regenerate hair cells. So this was a serendipitous finding from a study of gentamicin damage to inner ear hair cells in the chick, where one of the residents in my program was, just sort of counting hair cells, and he came back to count them at a later point in time just to see if there would be more degeneration, and noted, in fact, that they were coming back, which was, he was made by Ed Rubel to go back and do that experiment again. And in fact, again, he found the same result. There are many, many laboratories all over the world looking at how we can regenerate hair cells, and that would certainly be a boon to treatment. However, even if we do have some substance that can be injected into the ear to regenerate hair cells, there are still barriers. So any inner ear treatment would likely have to be injected into the ear, and that can be done in the clinic or in the operating room, depending on the type of injection that's done. Inner ear delivery is required at this point in time. There's a blood labyrinth barrier, much like the blood-brain barrier. And if you take a drug systemically, it has to be at very high levels in order for it to penetrate into the cochlear fluid. So it's unlikely that in the near future we'll have a pill for hearing loss, but I certainly hope at some point in time we will. So gene therapy is also being investigated in several labs to treat inherited deafness. And one such lab is that of Wade Chen, who's an investigator in our intramural program, or the research program housed at the NIH. And his studies are in Wurler mice, which are a mouse model of Usher syndrome. And Usher syndrome is the most common cause of deafness and blindness in people. And many of these individuals also have balance dysfunction, and that's why these mice are called whirler, because they actually whirl around. And so he's developed a technique for injecting gene therapy into the inner ear in this mouse model, which has shown some success, and plans to do further studies and hopefully be able to introduce this treatment in humans. So I wanted to shift gears a little bit and talk more about hearing aids. So hearing aids are a very good treatment for hearing loss. And as we've discussed, there are about 30 million plus Americans who have hearing loss, many of whom could benefit from wearing hearing aids. However, the percentage of US adults who have hearing loss and wear hearing aids is only about 14%, which is shockingly low. And so it's usually said, well, hearing aids are so expensive, and hearing aids are very expensive and probably are much more expensive than they need to be, as I'll talk about later. But if you could provide free hearing aids for everybody, then presumably everyone who needs one would use one, correct? No, it's not correct. Because in Europe, where hearing aids are provided free of charge because of socialized medicine, only about 25% of people who are candidates for hearing aids wear them. So cost is not the whole story. Stigma contributes. So there's ageism, which is a factor. Accessibility. So not everybody really knows how to access hearing healthcare or can go into a store and an audiologist's office and buy a hearing aid. So there are many advances that I think will help with this, as I'll talk about. But one thing that I wanted to address right now in the next few slides is the perception that hearing aids don't work well. And so hearing aids are of great benefit, but there are certainly many situations in which hearing aids really fall short. And the primary way that they fall short is hearing and listening in difficult listening situations, such as multiple talkers, such as at a cocktail party, something like that. Music is not usually processed very well by hearing aids. So there are many situations where people still do struggle. So you probably all heard about advances due to machine learning and artificial intelligence. And there are many programs now, research programs that are using these technologies to try and improve the way that both hearing aids and cochlear implants work. So these are technologies that are able to take great amounts of data and analyze them very quickly and be able to reproduce the patterns of normal natural speech. So I want to tell you about a couple of research programs to develop better hearing aids. And this is the work of Delang Wang and his colleagues, who used machine learning algorithms to separate out the components of a complex speech signal, be able to choose the signal that's the speech that's being attended to or that the speaker wants to listen to, and then amplify selectively that part of the overall signal. So something about the separation of these signals is shown on the left. On the right is a graph showing that the unprocessed speech is not heard as well as the processed speech, which is in the hatched a graph line. And that's shown for both normal hearing, interestingly, and for hearing impaired on the right. So if you can't see, normal hearing is here. So the processed speech is heard better, even by normal hearing individuals, but there's a huge benefit for those with hearing loss. And now if this works, I'm going to play you what it sounds like to have a mixture of all of the signals together. And then later what the Deep CASA, which is their speech processing strategy, sounds like when these sounds are separated. So this is the mix. And this is the processed speech.
Bring your best compass to the third class.
It muffled the high tones of the horn.
So those were mixed initially, but once they're separated out, there's a dramatic improvement. And then the next example is just fascinating to me. So this is brain-controlled hearing aids. So these brain signals are measured by an EEG cap over the auditory cortex. So it turns out that in the auditory cortex, there's a lot of separation of signals due to attention. So the signal that's being attended to is reproduced with a great deal of fidelity in the cortex against the background of those unattended signals. And so the upper left-hand part of the figure shows in dark blue, the attenuated sound signal, and in the black is the neural signal. So these are superimposed over each other. The unattended signal is shown below in the light blue. So that correlation is not as good. And then on the right, there are the 3 speakers. And the speaker that's being attended to is then separated out and amplified. So the next slide has another reproduction of what this sounds like. So initially, the male and the female speaker are together. And then the algorithm switches to pay attention to the male speaker and then the female speaker. So I think you'll see how dramatic this is as well.
How to be a shepherd. Dogs are great companions for a variety of people.
Especially when you know how to do it.
Have you ever thought about having your own
Shepherds
companion?
can be found all over
If you
the
do
world.
not have a dog yet,
Any
you
place
need to
from
understand the
deserts of
difference
Israel
between
to
breeds
the
before
highlands
making a
of
choice.
Scotland.
The breed of a
Find a good
dog
place
can
to
have
live.
significant impact on its
Many shepherds
personality,
like to live in mountains.
as well as its size,
If you want
health,
to do this,
and
it
required
would be best
maintenance.
to move to Wales or
For example,
Scotland. If you
long-haired
want to
breeds,
live in the United
like
States,
collies,
move
may
to
be
Idaho
useful,
or
but they
Wyoming.
require frequent
Buy
brushing.
a sheepdog.
If you do not have time
Some
to devote to
sheepdogs are better
weekly
than
or
others.
even daily maintenance,
You would do
you may
best
need
to
to
look on a
choose a
dog
different
market
breed.
online or see
the
if you can
American
find a breeder.
Eskimo is bright.
So I think we are a ways off from this. So this is a way of using the brain and auditory attention to really focus in on a signal. But I think it's so exciting to think that something like this might be possible to do. No, go away. And the next thing I wanted to show you isn't related to hearing, but I just think it's so cool and it uses similar technology. This work was done in the lab of Eddie Chang, who is now chair of neurosurgery at University of California at San Francisco. And the person who did the work that I showed you in the last slide actually trained in his lab. And so Eddie Chang is an epilepsy surgeon. And so in order to detect the area of the brain that could potentially be ablated to reduce seizure activity, he implants sheets of electrodes over portions of the brain in the operating room and then monitors these patients for epilepsy episodes in the hospital for a week or 2 afterwards. And as part of this, he has done some research that I think is so interesting and exciting. And the goal is to be able to synthesize speech in patients who cannot speak. So these are individuals with ALS or potentially a stroke who can formulate the thoughts and the speech patterns, but actually can't articulate. And so what actually he developed is a way of recording not from the auditory cortex, but from the speech cortex. So this is as the person is visualizing or formulating thoughts translated into speech, the speech signals that that move the articulators are actually that's what's being measured in the motor cortex. And then that is being translated through deep neural networks and the brain-computer interface into a way of producing speech. And so you'll be able to hear this, I think, very nicely.
Most fascinating process.
She feel we did the most fascinating process.
The proof that you are seeking is not available in books.
The proof that you are seeking is not available in books.
So again, I think this holds great promise for the future.
Shipbuilding.
All right. So now I'm going to talk about advances in hearing aid accessibility. So the goal is that we would like for everyone who could benefit from hearing aids to be able to use them, regardless of where they need to go to get them or how much they need to pay for them. And hearing loss is a huge public health issue that's neglected in most mainstream models of healthcare. So this is just really reiterating what I've already told you about how many people need hearing aids, how few people use them, and the economic burden of hearing loss in this country, which is estimated in billions of dollars. Hearing loss is an increasing public health issue, especially with our aging population. So we know that hearing loss leads to impaired communication, loneliness, depression, cognitive decline potentially, and a greater risk of falls. And falls are actually the leading cause of death from injury in seniors. And hearing loss increases with age. So about 10 or so years ago, the NIDCD became very interested in this as a public health problem. So before that, I think our institute was focused mostly in basic science research, and really not much was done in public health. And I think that that was true to a certain extent across the NIH. But I think it's been recognized more and more that the translation of research into public health is really what our goal should be. So in 2009, the NIDCD held a workshop to determine what the research needs were and create a new scientific priority in this area. So since this time, we funded many, many studies that look at affordability and accessibility of hearing healthcare. This was helped along by the President's Council of Advisors on Science and Technology, which is called PCAST. This was Obama's PCAST, and in 2015, the report looked at all of the issues related to hearing treatment, especially in seniors, and called for action from the FTC and the FDA to enhance the pace of innovation, decrease cost, and improve the capability, convenience, and use of assistive hearing devices. This was followed by a landmark consensus panel conducted by the National Academies of Medicine that I was so privileged and pleased to be a part of. And that was funded by the NIDCD and the National Aging Institute, and came to similar conclusions. So both the PCAST and the National Academies report made a recommendation that the FDA provide for a new category of hearing aid that can be sold over the counter. So I think this is mostly what I've already told you, so I'm going to skip this. So as of January of this year, the NIDCD has supported 25 projects on accessible, affordable hearing healthcare. Clinical trials have been published which have shown similar benefit between the over-the-counter service delivery model and full service purchase. So some of you know that most hearing aids in this country are sold by audiologists and hearing aid dealers. And if you go into one of these practices, they will typically tell you that they will sell you a pair of hearing aids for $7,000 or $8,000. You can buy hearing aids that are less expensive at Costco that are actually the exact same hearing aids. So the cost can vary substantially. The VA is the largest purchaser of hearing aids in the United States, so they get bulk rates, and they pay less than $350 a hearing aid. And it's estimated that hearing aids actually cost about $50 a piece to manufacture. So none of this cost is because the hearing aids are very effective. The cost is because this is the business model. There are 6 hearing aid manufacturers worldwide, and they have a great investment in keeping these costs high. So the recommendation to sell hearing aids over the counter is based on the fact that very effective devices can be sold for not very much money, and that they can be designed in a way that people can use them without the benefit of professional advice. Professional advice is still very valuable, so I'm hoping that there will be models where audiologists can provide support for these over-the-counter devices. I'm very, very hopeful that, that having these available over the counter will lead people to try them earlier and not break the bank when they do decide to do so. So based on the recommendations of these 2 groups then, Elizabeth Warren and Chuck Grassley introduced a bill that was passed in 2017 that required the FDA to create a first of its kind category of over-the-counter hearing aid for adults with mild to moderate hearing loss. So these are not adults with very severe hearing loss, certainly not with profound hearing loss, and it's not for children. This specifies age 18 and above. And the law stated that the FDA had to develop these regulations within 3 years. So 3 years came and went, and they said, well, because of COVID, we didn't quite get around to it. And I saw this morning that Warren and Grassley had actually introduced another bill that, if passed, would require the FDA to release their regulations within 30 days. So I have seen the version that they put out for public comment, and I know that they are still working on it. So hopefully this will come about sooner rather than later. And now I just wanted to tell you about a few of the programs that we do support that help to widen the net of populations for whom hearing healthcare can be more accessible. So one problem is there are too few hearing healthcare professionals, and they are not co-located where the populations live, particularly not for inner city or for rural populations. And so this study was conducted in Arizona. And you can see here a map of Arizona, and the little dots are where the hearing healthcare professionals practice. Most of them are centered around Phoenix and Tucson, and maybe a few around Flagstaff and other northern areas. And then the population density is shown by the density of the orange color. So you can see that there are quite a few practitioners, but they're certainly not distributed throughout the state. And so what this group did is they went actually to a border county on the border with Mexico, which is a Spanish-speaking area. And they reached out to the community and they said, we were really interested in helping develop this program. What is important to you? So this is a really good example, and this carries through in the rest of the examples that I'll show you of community-based participatory research, not just going in and saying, we're gonna do this program for you, but going in and saying, how can we help? We think this is a real problem. We think you think it's a real problem, and how can we work together? So this group conducted a 5-week Spanish language health education program for older adults. And the outcome was that after a year, 7 of 9 participants with hearing loss had sought follow-up for their hearing loss. So that was a successful program. This next program is very similar, but it was conducted by 2 investigators from Hopkins, Frank Lin, who has the Achieve study, and Carrie Neiman, his colleague there. And they developed a program again of participatory research in inner city Baltimore. And these were low-income minority older adults, and they provided this program, which has been very successful. They also have some data shown on the right that shows evidence of hearing healthcare disparity in the US. So hearing aid use in adults who are white are about 20%, but individuals who are Black or Mexican American are only about half that. This is a similar study in Alabama, this one conducted with a van that goes around to underserved areas and provides state-of-the-art hearing healthcare. So these are programs for adults, and these next 2 are programs for children. This is a program developed by Susan Emmett, who used to be at Duke, recently moved to Arkansas, but she was very interested in access to hearing healthcare. And this particular program she developed in Nome, Alaska. So many areas of Alaska are very remote, very difficult to reach. And Nome is like at the ends of the earth. So she developed this program of school-age hearing screening and treatment for otitis media in this population, which has been a model that she's then extended to other areas in the United States. And this final example is in rural Appalachia in Kentucky. So this is a program developed by Matt Bush at the University of Kentucky. And it's based on the premise that newborn hearing screening is required in all hospitals in the United States, and it's carried out with about 98% efficiency. But the problem is that only about 65% of children then have follow-up. So this lack of follow-up in 30-some percent is due to many, many factors, but is particularly a problem for low-income families who may have multiple children at home, who don't have transportation to go and get follow-up, who may not understand why they need follow-up. And so this is a program that is studying the use of a patient navigator to help these families navigate all of these difficult issues and comply routinely with follow-up and treatment of their children. And the diagram on the left I thought was interesting because it shows risk factors for infant hearing loss, and minority race is the most predictive factor of infant hearing loss. So this is certainly a problem in underserved communities. So last, I just wanted to wrap up by telling you a little bit about the NIDCD mission and vision. So we're currently in the process of developing a new strategic plan. Our mission is mandated by Congress. It's in our congressional language, and that's to conduct research and research training in normal and disordered processes of hearing, balance, taste, smell, voice, speech, and language. And our vision is to advance the science of communication to improve lives. Our budget, with the recently enacted budget, unfortunately, we had to wait 6 months for this with continuing resolutions in the interim, but we finally passed the $500 million mark. So we had a healthy increase. NIH has had tremendously wonderful support from Congress. It doesn't matter if members of Congress are Republicans or Democrats, they all love the NIH. So I feel very fortunate for that. Our pay line is one of the better pay lines of the institutes at the NIH, and we're able to devote quite a bit of money to paying grants and also high program priority projects. So we, in that smaller program, try to fund particularly beginning investigators or investigators who might be disadvantaged for some reason, or who are fulfilling a need that is lacking in our portfolio. On the left, you can see the breakdown of the different areas of our mission. So about 51% of our funding goes to hearing research, and language is probably next, and the rest of the areas as shown there. This is not dictated by any mandate that we have, but is simply the result of what applications come in and how they're scored. Most of the funding goes to supporting research project grants, which are R01s and R21s. We spend about 5% of our budget on training and career development, 9 or 10% on intramural research that takes place on our campus, which is almost all hearing related. And then other is shown in the box on the right. So SBIR and STTR grants are small business grants. So they're collaborations between industry and academic partners. And this is actually a set aside that's mandated by Congress. So these are dollars that we have to spend and fund many really wonderful programs through these grants, but it is often a really good way to get funding for industry related projects. So living your best life, coming back to how hearing well contributes to healthy living and healthy aging. I just wanted to re-emphasize some of these points. So a recommendation could be to have your hearing tested if you suspect difficulty hearing or age 60 or older. Educate yourself about the availability of assistive devices and technologies that can make listening easier. So there are many options out there, amplifiers, captioning that can make things a lot easier. Learn about insurance benefits that are related to hearing care as you comparison shop. So some insurance does cover hearing aids. Blue Cross Blue Shield sometimes does. Medicare Advantage plans, which are the HMO type Medicare plans, often will cover hearing health care. Don't hesitate to get hearing aids, and don't wait till you're struggling to hear to get help. Those around us usually notice that we're having difficulty hearing before we do. Listen to them. My husband complains about my hearing all the time. Be a well-informed consumer. More expensive does not equal better. And prioritize effortless communication. So make things easier for yourself whenever you can. So I was very pleased when I was researching Virginia Tech online before I came to learn that your motto is that I may serve. I think that's a really wonderful motto. And after spending a day here, I can see that that's really taken to heart. This is a wonderful place. NIH's motto is turning discovery into health. So I think we share the mission to serve the public by providing evidence-based research that leads to improved health. So thank you so much. And I look forward to any questions.
Thank you.
Yeah.
Thank you so much, Dr. Tucci. Fascinating lecture. We do have time for a few questions, either in the room or online if they pop up there. So questions, if you have one, raise your hand. Yep, and stand up and belt it out if you would. Oh, okay, well, just belt it out.
You spoke a great deal about hearing and how the efforts of communication focusing on hearing aids and hearing aiding technology. What about that?
Thank you. You spoke a great deal about hearing aiding technology, amplifiers, cochlear implants. What about on the policy side of increasing communication from the other direction, not just people with hearing, helping people with hearing loss hear better, but communicate and interacting with their environments better? For instance, I don't know, focusing on improving auto captioning technology or communication training with physicians to better be able to communicate with patients who have hearing loss that may not be able to hear what the physician is saying to them as well. Is there any work going on in that direction?
I think that there is some work. I don't know that there's policy directed work, but we've actually looked at what aspects of healthcare in a hospital setting are most difficult for people who have hearing loss. And you know, I think some of it's predictable, but some of it's surprising. So one thing that poses problems, I think, for a lot of people is that physicians will come into a room and the computer is there, you know, we're supposed to do all of our charting on the computer. So you look at the patient, hi, how are you? Why did you come here today? And then you turn around and sit at the computer and start to type and keep asking questions while you're looking at the computer and not the patient. So I think awareness is a huge part of it. I think once you draw somebody's attention to the fact that this person really can't hear anything that you're saying, you know, that causes them to change their behavior. So I don't know that that's a policy issue. The other issue that you mentioned about closed captioning and assistive devices is a really, really good one. And so I think there's an increasing awareness of the need for that. Some people have noticed that with Zoom, you know, with all the virtual meetings that we've been doing, closed captioning is often something that's put on to those virtual meetings or, you know, to the recording afterwards so that people with hearing loss can really use that closed captioning to make sure and fill in any blanks. So, you know, I think that we're getting better, but I think that a lot still needs to be done. And so that's a lot of what we're looking at with the Landsat Commission on Hearing Loss is making sure to call out these technologies and say, it's really a shame that these aren't used more broadly in many, many settings. So I agree with you completely. Yeah.
We had a couple questions online. I'll just try to do one from memory here. One person asked about chemotherapy and damage to the inner ear hearing apparatus, what we know about that.
Yeah. So cisplatin is a very common drug used for chemotherapy, and we know that that causes hearing loss. Actually, we have an intramural investigator, our scientific director, who has discovered that some statins may be protective against cisplatin-related hearing loss. And so she's going to be conducting a clinical trial. And there are other groups who have also identified other drugs that may be protective against cisplatin-induced hearing loss. So we find that cisplatin actually sits in the cochlear hair cells longer than almost any other cell in the body. And that's presumably one of the reasons why it's so ototoxic. So I think the research is coming.
If I may ask you a question. Yeah. So the falls in older people, when you talked about the relationship to hearing loss, was that was that just hair cell damage of the vestibular apparatus, or hearing loss per se without vestibular damage increases the likelihood of false?
No, I think that's a good question. And there is, I'm using this, there is ongoing research in this area looking at both audiograms and vestibular testing in older adults. But I don't know that we know the answer to that question exactly. Yeah. But presumably, I think that it's safe to assume if there's some hearing loss, there might also be some vestibular loss. Yeah.
And just a corollary to that, is there any evidence that using hearing aids as you age prevents further hearing loss?
No, I don't think so.
Okay.
Yeah, I don't think so. I think it's all an issue about maintaining auditory pathways. So there have been studies that have shown, for example, if there's a high frequency hearing loss, that the areas in the brain that process high frequency sounds are actually shunted to process more low frequency sounds. So there's plasticity that occurs in the brain that adjusts the way that you hear. So that's one reason why we always tell patients who get hearing aids to use them for at least a month before you decide that they're, not going to work for you, or they are going to work for you, because the brain has to adapt to the new introduction of that signal. Yeah.
Anthony, go ahead.
So I'm curious about the balance between mitigation of hearing loss, which in some ways seems like throwing up your hands and saying, we're all going deaf, live with it, or the actual prevention, and also stratifying people for risk based on genetics, as well as environmental and socioeconomic status. And so where do you think the balance in that lay? And also what would you identify as the priorities for really beginning to think about making sure that the next generation, when they hit 60, don't need to go to Costco or wherever to get their hearing aids?
Well, I think the big issue that causes hearing loss that is preventable is noise. And so making sure that for middle-aged working adults, if they're working in a noisy environment, that they have proper ear protection. Musicians are at risk for hearing loss. So you can get earplugs that are specially made for musicians that let some sound in but protect you. We have, in the symphony, if you're sitting in front of the tuba, you're going to have a lot of sound exposure. So now they're starting to construct plexiglass shields to protect people in front of loud instruments. Kids that use, listen to loud music through earphones are at risk. In a car with, some bass booming, that's putting people at risk. So I think that noise is probably the major preventable cause of hearing loss. And education is the way to do that. It's a huge problem worldwide. There are major campaigns globally to encourage people to, industries to mitigate against noise-induced hearing loss, which is sometimes hard to do unless they're required to by law. And it's really, really hard to get teenagers not to listen to loud music. But, you can say you're going to be deaf, but, they don't care in the moment. So, that's mostly an education thing. But hopefully, we'll have more opportunities to intervene earlier before people do start to lose hearing. Yeah.
Maybe folk music will come back and vote. Okay, time for one more question. Yep. Will you get a microphone?
In a subset of hearing loss patients where there's auditory nerve damage, comment on that area?
So auditory nerve damage would mean auditory neuropathy, and that's very rare.
Or infarct.
Or infarct, yeah, could be, but it's pretty rare just to have an isolated auditory nerve injury. So usually the term sensory neural hearing loss is a little bit of a misnomer because it's usually sensory. The neural part, the nerve, the auditory nerve is generally well preserved, which is why cochlear implants work well, because they're stimulating the auditory nerve directly. Yeah.
Okay, please join me in thanking Dr. Tucci for.
Thank you all.
Perfect. Thank you.